One important topic in algebra and also in pre-calculus is transformation of functions. Transformation of functions means that we take a function and we do something to it that makes it move or makes it stretch or shrink or change shape. And there's certain rules that apply to all functions. So we're going to go over these rules using a few example functions and then summarize them at the end. So starting with this function right here, f of x is equal to 1 minus the square root of 1 minus x squared, which is a semicircle, the upper half of a circle of radius 1. And we're going to look, and this circle has three key points, negative 1, 0, 1, 0, and 0, 1. And we're going to see what happens to those 3 points and then the entire graph as we do different transformations. So the first transformation we're going to do is add 2 to the entire function. So here's my f of x function. I substitute that in for f of x, the square root of 1 minus x squared, and add 2, which means I'm basically taking the entire function, figuring out my y value, and then just adding 2 to it. So I'm adding 2 to each y value. So 1, 0 becomes 1, 2, or negative 1, 0 becomes negative 1, 2, 0, 1 becomes 0, 3, and 1, 0 becomes 1, 2. And then that's my whole graph. The whole thing shifts up, does not change shape. I can do the same thing when I subtract. The entire graph shifts down 2, but does not change shape. So outside the function makes the graph shift either up or down, adding or subtracting outside the function. Now if I add inside the function, like this, x plus 2 inside the function, it changes the input value. In other words, before I do anything to this number, I add 2 to the number. So I take x, add 2 to it, square it, and then subtract it from 1. So what effect does that have on the graph? Well, it turns out adding inside the function shifts the graph to the left, while subtracting inside the function shifts the graph to the right. Why does that happen? It seems like it would be the opposite of that. Well, think about my original points. When I put 1 into my original function, I would get 1 minus 1 squared, which is 0. If I put 1 into my new function, I would get 1 minus 3 squared, which is 1 minus 9, and that's an imaginary number. So that number is no longer in the function. I can't use the variable 1. The biggest this quantity can be is 1. If it's any bigger than 1, then I'm going to get an imaginary number. So what values would make this quantity equal to 1? Well, either negative 3, because I'd get negative 1 squared, or negative 1, because that would give me 1 squared. And those now become my two places where y equals 0, is negative 3 and negative 1. If I put negative 2 in here, I get 0, and then I'd have 1 minus 0, and the square root of 1 is 1, and that's where I'd get this point. So because we change what happens to x before we do the rest of the procedures to the number, before we subtract it from negative 1, before we take the square root, it acts in an opposite way. We actually have to kind of get back to our starting point before we apply the rest of the function. So I have to get this back to a number that works in this function that I can take the square root of. Oops, computer glitch there. Alrighty, that's what happens when you have a touch screen, very sensitive. Alright, let's switch down. So inside the function now shifts left and right, and those are both called translations. Now let's shift down a little bit and take a look at our dilations. Okay, so now we are multiplying the function outside the function here, 2 times the entire function, and this is my entire function again. So what happens is I put in values for x, I figure out what y is, then I multiply it by 2. So all my y values are twice as big as they were. These two y values are 0, so they stay the same because 2 times 0 is 0. This was the point 0, 1, so it becomes 0, 2. I make it twice as big as it was before. Here, it's half as big. So instead of 0, 1, I have 0, 1/2, and these 2 points stay the same. So in general, When I multiply outside the function, it stretches the graph away from the y-axis. For example, if there are any points below the y-axis, they would be twice as far below the y-axis. Multiplying by a number less than 1 causes the graph to get shorter or closer to the x-axis. I'm sorry, I think I said before y-axis, I meant x-axis here. It stretches away from the x-axis or it stretches towards the x-axis. I probably should also say that it would stretch toward the x-axis if I, see if I can draw that in there. This is hard to do with a mouse or a touchpad, I should say. Okay, reasonable facsimile of an arrow there. There we go. Not a very good one. Okay, it's not behaving. All right, there we go. Okay, now if I multiply inside the function, I am changing x, squaring it, and then subtracting from 1. So once again, remember, I can't subtract anything bigger than 1 from 1, or I get the square root of a negative number, and that would be imaginary. So when x is 1/2, this would be 2 times 1/2, which is 1. 1 minus 1 is 0. So when x is 1/2 now, y is 0. Or negative 1/2, since I'm squaring it. Negative 1 squared is also 1. So notice how the graph actually has to shrink towards the y-axis. So multiplying inside the function makes the graph thinner. It makes it shrink towards the y-axis. Once again, doing the opposite of what we expect when it's inside the function. Similarly, when we make this 1/2 times x, I would have to make x equals 2 to make this quantity equal to 1 and have y be 0, or negative 2, because negative 1 squared is also 1. So when I multiply 1/2, the graph is twice as wide, twice as far from the y-axis. Okay, so multiplication causes the graph to stretch or shrink. Notice that when you multiply outside the function, it affects y. The x-intercepts do not change, and it does about what you'd expect. Twice as big, half as big. When you multiply inside the function, it affects the x direction, the y-intercept does not change, and it either gets half as wide here or it doubles. In other words, it shrinks when you multiply by a number bigger than 1. It stretches horizontally when you multiply by a number less than 1. Okay, okay, next, the last little group of things we're going to look at are reflections and absolute value. So reflections. Following along with our pattern, if we multiply by negative 1 outside the function, it flips the graph upside down. The reason it does that is it is basically taking the opposites of every y value. So negative 2, positive 7 becomes negative 2, negative 7. 1, negative 2 becomes 1, positive 2. The y values that are 0 stay 0, so the x-intercepts do not change here. So this is a vertical reflection over the over the x-axis. When I multiply by negative x, when I change x to the opposite of x, then all of my x values become the opposite of what they were. And when my x values become the opposite of what they were, that serves to give us a reflection across the y-axis. So 3 positive 2 becomes negative 3 positive 2. 1 negative 2 becomes negative 1 negative 2, and the point on the y-axis stays the same. Last groups of transformations involve absolute value. When I take the absolute value of the entire function outside the function, once again, anything I do outside the function is affecting the y value. So all of the y values I'm taking the absolute value of, which means positive y values stay the same, but negative y values become positive. So if this is my original graph, then positive parts of the graph in the y direction stay the same, but the parts that have negative y values become positive. So the entire graph, the part that's below the x-axis, reflects above the x-axis. So for example, if I had the graph x cubed, so that I'm kind of tracing along, that's what x cubed would look like. This part of the graph, when I take the square root of x cubed, would stay the same. This part would change. It would flip above the x-axis. Now, the absolute value, or f of the absolute value of x, so if I take the absolute value of x, this one's kind of a little different. It's a little trickier. So what happens here is, originally I have the point 3, 2, and 2, -1, and 1, -2. When I take the absolute value of x, these 3 points stay exactly the same. And actually the 0, -1 also does, because the absolute value of 0 is still 0. But when I go to the other side of the graph, this part of the graph changes, so I've crossed it out. It's no longer there. When I put 1 into the function, it becomes -1. And what does -1 do? -1, I'm sorry, this is not 1, this is -1. When I put -1 into the function, it becomes +1. +1 corresponds to a value of y equals -2. So now -1, -2 is also a point. Okay, so -1 becomes +1. +1 pairs up with -2, so now -1 pairs up with -2. -2 used to pair up with 7, but now -2 becomes +2. +2 pairs up with -1, so now -2 pairs up with -1. And then the same thing's true with -3. I actually don't have -3 over here, but -3 would become +3. +3 pairs up with 2, so it would also do this. So the graph looks like now an even function. So that's what the absolute value is. Now this one you don't see a whole lot. This doesn't happen a lot in practice. So this would, I'm not testing you on this. However, some of your homework problems do have this in it. So especially some of maybe a bonus problem. So that's what this one's for. Now let's just do a quick summary. I have a little chart here. In general, anything that's done outside the function affects the y direction. Anything that's done inside the function affects the x direction, and also it does the opposite of what it looks like when it's inside the function. Inside the function is called the argument of the function. So now let's look at addition and subtraction. So addition goes up, subtraction goes down. Remember, this does the opposite of what you think on the x direction, so addition inside the function makes the graph go to the left. Subtraction inside the function makes the graph go to the right. Okay, now multiplying by 3 outside the function makes the graph 3 times taller. 0, 2 moves to 0, 6. Okay, 2 times 3 is 6, 3 times taller. So you're multiplying each y value by 3. If you multiply by 1/3, then it's 1/3 as tall. So here's an example of a square root graph, and now it's 1/3 as tall. Okay. Multiplying inside the function does the opposite of what you think. So you multiply by 3, it's 1/3 as wide. So if it went out to 3, now it's only going to go out 1 away from the y-axis. 1/3 means it's 3 times as wide. So if I have the point 2, 3, it becomes 6, 3. And -2, 3 becomes -6, 3. 1, 1 becomes, actually 1, 1 should become 3, 1. I wrote 2, 1, that's supposed to be a 3 there. Darn it. Printed notes will be slightly wrong there. I probably ought to change that. Okay. Then when we do the reflections, looking at the graph, the square root of x, if I multiply outside the function, so negative f of x or negative square root of x, it flips across the x-axis upside down. However, if I do f of negative x or the square root of negative x, it flips horizontally across the y-axis. And I didn't summarize the absolute value. You can go back and look at those. So hopefully that'll be helpful, because these transformations will apply to any function. And so knowing the parent functions plus the transformation gives you a big army of tools to use in your transformations.